Hey everyone, my name is Erik Bohnhorst. I'm a product manager at NVIDIA focused on confidential computing. My team is responsible for some of the infrastructure software that NVIDIA is building. So as an example, the software in order to use GPUs with Kubernetes, software to use NVIDIA GPUs with hypervisors, and a couple other software. This is my first time at the CC Summit. I'm super excited. I'll say the experience, the technical depth that is presented here is amazing, and I'm very happy to be here. But I'm not the only one that is here, and I warned my colleagues, at least some of them, NVIDIA is confidential computing is very strategic to NVIDIA. So if the NVIDIA people could just raise their arm just to show how many there are. So if you see any one of us in anywhere, feel free to engage us. We do not have, most of us, the green sticker that says, please talk to us, but please do. We're here to network, and we have people from architecture, engineering, security, solution architects, marketing, everybody is here. So feel free to engage us. So having said that, this presentation is going to be about building trusted AI factories with NVIDIA accelerated confidential computing. And I want to start with really that the point that I'm trying to make is AI is useful now. I personally have been in this situation, I think most of us have been, that AI has been cool. We were able to use AI to basically become more efficient in what we're doing. For example, gathering information or learning about something new very quickly because we can ask the AI to explain it in a way that is actually easy for us to understand. To now AI as being useful as it can actually do work for us. Agentic system, autonomous agents are able to do that for us. So we're at this inflection point where AI is useful, and because it's useful, we want more of that. We want to create more useful impact, we want to create more output. And as I think everybody knows, we've heard it here before, AI as an agents, they reason, that means they think, they infer, and they do more and more and more, and that drives just the request for compute and for inference up and up and up, and that's why we see all this demand for accelerators in the industry right now. So having said that, at NVIDIA we've been basically explaining to the industry, to our partners, to end customers, that we're now at the point where we're building factories, AI factories or agent factories. And we fully understand that a factory is going to be measured, and the measurement of a factory is based on the cost per token. So the more tokens you can generate in a basically defined perimeter of power, the more output, useful output you can generate, and the more valuable your AI factory will become. We do understand, and we see it internally as well. It is distributed, so some of the AI will run locally where our most sensitive data, so on-prem, resides. Some of the AI will be in the cloud, in the neo cloud, wherever it may be. And the AI, in some cases, will have to move where the data is, and sometimes we're willing to move the data where the AI sits. Data privacy absolutely matters, I mean, I think I'm preaching to the choir here. And security has to be designed in right from the start. If you don't define and build in security right from the start, there's a great chance that your agents will do something that which will make your company or yourself show up in the evening news. And I guess we don't want that. I've said it, I kind of said it already, but I think we've gotten to the point that in the past, data centers were there to help us. They were storing files, they were doing computation based on what we as humans have asked them to do. Now, data centers, not everyone, but conceptually speaking, data centers are creating output. They're running agents, they're doing work for us. So it is important to understand that the more AI output, so the more tokens we're generating, the more valuable output we're taking, the more potentially revenue we as a company are creating. And that is driving huge consumption of compute these days. So when it comes to agents, NVIDIA, we've been using agents. We are using agents deeply. Every employee is asked to use agents, try to find out how we can become more productive by the use of agents. and we do that all the time. We learned in our own deployments that once you deploy agents, or you're intending to deploy agents, right, security and trust is an essential role that you need to cover. I do want to quickly share about NVIDIA OpenShell. So if you've heard the recent keynotes that Jensen did, OpenShell was always mentioned. And think of OpenShell as an open source community project that we're engaging to basically manage the behavior of agents. And then, of course, NVIDIA Confidential Computing, which we'll cover during this session. So when it comes to OpenShell, and I'm not going to pretend that I'm an expert in OpenShell, but what I do want to say is when we started deploying agents, it became very obvious that the security that we were applying, the compliance needs, didn't really match to the use of agents. So OpenShell is intending and is helping with managing the behavior of agents and so allowing us to apply policies and enforcing those policies. So think of it this way. You want to make sure that an agent runs in a sandbox, right? Could be any type of different sandbox, right? OpenShell will help with that. You want to apply policies, OpenShell can help with that. So for example, which systems call can an agent make? What part of the file system can it access? What type of network devices or network or remote services is it allowed to work with, right, in order to get data and to be productive. That's what OpenShell helps with, and it's very complementary to all the other software that is out there. All might be a little bit much, but have a look at it, and you will learn more about OpenShell, which is something that we are using internally, and we've seen tremendous amount of interest in the ecosystem of using OpenShell. To be honest, or to be transparent, the interest in OpenShell is unprecedented in the ecosystem when it comes from an NVIDIA, looking at it from an NVIDIA perspective. So many partners are engaging with us in the open community on OpenShell. The momentum is there, and it's tackling a nerve that everybody is trying to solve for right now. So what we did is we created a secure agent workspace reference design. So if you're not if you're trying to understand, if you're an end customer or a partner, how to deploy these autonomous agents, we wrote a reference design that uses OpenShell and some other parts to basically explain how we've done it, and we are constantly updating this reference design to make sure that our learnings are being projected externally. There's a QR code in case you want to learn more. Okay, let's get to confidential computing. Having been here for the first time, right, I don't think I have to explain what confidential computing is. That doesn't really make sense. You know this as well as I do. But I do want to share where we see momentum when it comes to confidential computing. What do we see as NVIDIA when people ask us, where do you see confidential computing being used? Where do you see the interest? And there are basically two primary use cases that have been coming up over and over and over again, and even more with every month that we have that we're out there. And the two use cases are, number one, model protection. Model vendors that have spent millions, if not billions in dollars in creating proprietary AI, right? They want to protect their IP, their model weights, and they do see, very often, the need to move their AI wherever the data sits. And confidential computing is very helpful for that use case. The second use case that we're seeing, not at the same quantity, but the second use case that we're seeing is protect my data. Protect my data so that nobody else can see it, or if I send my data somewhere, making sure that the operator that is hosting this confidential computing environment, or is hosting the physical systems, is not able to see my data. That's the second use case. And we see those two use cases over and over again. I guess not really, not revolutionary, and we kind of expected it. I don't know, but a couple of years back, we had an NVIDIA employee, Phil Rogers here. He was on stage for the keynote. I remember with him sitting in a room roughly 4 years ago. Swanko, one of them, was in the conversation as well. He said the model protection use case is going to be the use case for confidential computing. And the way that we want to do that, not the only way, is through confidential containers as well. And we'll speak about that in a second. So what we've done, and this is kind of preaching to the choir, is, right, NVIDIA is now in its 3rd generation of confidential computing with our GPUs, right? We had Hopper, Blackwell, and now we've announced Vera Rubin. What we do is we extend the hardware root of trust from the CPU to the GPU through isolation and encryption, right? Isolation as in virtualization, encryption across the CPU to the GPU, between the GPUs with NVLink, and then put zero trust enforcement on top of it with remote or composite attestation and policy, security policies. We're able to provide model owners, right, a safe landing spot that they can verify to run their models and basically move their IP to somebody else's operated hardware. So one thing that we hear when we are in our conversations with customers is what systems to buy. So what we've done is, and you might be aware already, we've had for many years now a program that is called NVIDIA Certified Systems. The intent of that program is to help end users, customers, make a confident decision about what systems are ready for AI use cases so that they can buy servers that have been tested and validated and with more confidence, right, choose the right system. What we've done this month, and we're extending it, we've expanded the NVIDIA certification program to include confidential computing testing. So we're working with the OEMs and ODMs, right, HPE, Dell, and the like, to make sure that they're testing their systems so that confidential computing runs on the system performantly as well. So that should give you as a partner, right, or as an end customer, a way to quickly identify which systems are capable and useful for confidential computing. Okay, I mentioned confidential containers a little bit, but we see primarily 2 deployment methods for confidential computing: confidential virtual machines and confidential containers. It's not that one is better than the other, they're just different, right? Depending on the use case that you're trying to see. Confidential virtual machines has been out there for a couple of years, right? We've seen it in cloud service providers quite a lot, and we partner with them, and we're very happy to see confidential virtual machines grow in that space. What is new, though, is confidential containers. So NVIDIA has just G8, right, the use of confidential containers with NVIDIA GPUs. The team has been working in the upstream across all the different projects to make this possible. So think of Kata, Trusty, and the alike. So now there's an upstream based reference architecture that, right, there's a QR code that you can have a look at that allows you now to use your Kubernetes distribution, extend that with confidential computing capabilities to run your models that are potentially packaged as containers today, right, on Kubernetes easily. So that's new and something that we've heard a lot of demand for in the recent years, actually. So when it comes to confidential containers, I do want to call out one of our partners, Red Hat. There's also a session on Red Hat later today. Yeah, there they are. But the point being is, we did the work in the upstream. We did the work in the upstream, not only us, but the community did the work in the upstream. We were heavily invested in the upstream. And Red Hat is the first partner of ours, and we believe there are going to be many, many more that have a downstream product that provides commercial support for the confidential containers architecture. So enterprises can now run confidential containers with Red Hat OpenShift. Red Hat is, though, not the only partner. We have many partners, right? And if you know how NVIDIA goes to market, you will know that, right, we build great technology, right? Performance is, right, the DNA of the company, but we work across the ecosystem to make sure that our technology actually ends up at an end customer and is useful for an end customer. We work across cloud service providers, OEMs, software vendors like Fortanix, Red Hat, Anjuna Opaque, Edgeless, and Equity Labs, but also model providers that are using our technology. That's how NVIDIA goes to market, and we always hope to extend that. So last but not least, I want to speak about performance. In many of the conversations that we have, either with end customers or partners, right, a common question is, what is the performance impact of using confidential computing? So we spent quite a lot of time in the recent months to speak or to validate the performance impact of using confidential computing. So what I'm showing here is what we've did is, and we see confidential computing primarily used in inference use cases. So all the data that I'm showing you are inference-based. And we'll share a blog, and we'll release a blog in the near future. But on the left-hand side, you basically can see we're testing on an Intel TDX system, and we're using Qwen 3.5 with the SGLang backend for testing purposes. Now, what is important to note here is you're able to get very close performance to near, to non-CC performance if certain optimizations are applied. The optimizations sit within the inference framework, in this case, SGLang. So the performance that we have achieved here is by including performance optimizations in SGLang, and I'll share in a little bit that how we're making sure that everybody gets these optimizations out of the box and that you don't have to worry about it. But also, these optimizations are required because in our current architecture, we're using a bounce buffer. With Vera Rubin, that is not necessary anymore, and these optimizations are not required, and just out of the box, you will get this performance. So what you can see is, and with performance, it's always the same, It depends on the use case, what the performance is, In this case, we're testing with, a certain concurrency, and you're basically seeing here, I think this is throughput, throughput per GPU, but you can see that, what the performance impact is of CC. Here's another example. In this case, it's again throughput with different input and output sequence lengths, and you can see the performance difference between the two, And this is with the performance optimization. So the performance impact is minimal when the optimizations are applied. Here's another example. In this time, it's time to first token. Performance impact is minimal. We typically, it's typically in the single-digit numbers, and this is what this is showing. And once we release the block, there's going to be more data so that you can reproduce this. Here's another example with time per output token, very similar. And here's the slide that I do want to call out is, as I said, the DNA of NVIDIA is performance. We want to make sure that you're getting the best performance out of our architecture. So we'll optimize whatever we can optimize. So we've learned that there are certain optimizations that apply, to having a bounce buffer solution today, And we've tested with SGLang as an example. We did the same with TensorRT LLM, our inference backend. And what we've done is, with the release candidate, and you see the version here in TRT LLM, we already applied all the performance optimizations required. So if you use TRT LLM, you will get the performance optimizations out of the box. When it comes to SGLang or Flash Info, which is used by SGLang, we have the PRs underway so that the next version of SGLang hopefully includes all these optimizations so that you don't have to worry and everybody gets these optimizations. Now, a question may be, what about VLLM? We are investigating, and we want to make sure that all these optimizations are available in VLLM as well. So we're validating which optimizations make sense for VLLM so that everybody gets these performance optimizations. So last but not least, Vera Rubin. There are three things that I want to call out, and you might have seen other presentations from NVIDIA employees where Vera Rubin was already mentioned. The things that I want to call out about Vera Rubin is, so in terms of performance, as I said, these performance optimizations that I just showed do not apply for Vera Rubin NVL because we don't use a bounce buffer anymore between the CPU and the GPU. We have TDIS. So that problem is gone. You get the performance out of the box. Number two, with our current architecture in terms of Blackwell systems, the trust boundary was basically within a system up to 8 GPUs. With Vera Rubin NVL72, the trust boundary is now 72 GPUs. So that positions this system, this rack scale system, ideally for these new frontier models or these new models that are much, much bigger and need much more compute. And then third, we're using TDIS, but the third point is with Vera Rubin, the Vera CPU is part of this. So this is NVIDIA's next generation CPU architecture, and that is confidential computing capable as well. So having said that, we have 5 minutes left, and I'm at the end of my presentation. So I want to thank you all for coming here. I hope that was helpful. And as I pointed out, there are there are so many NVIDIA employees. If it's about hardware, security, whatever it may be, we're here to answer any questions. Thank you very much.